Robert Stephenson built the Britannia Bridge to carry the Chester and Holyhead Railway across the Menai Straits in North Wales. Two immense independent continuous tubular beams were constructed on the shore of the strait. They were supported at 5 places, namely on the Carnarvon and Anglesey abutments and on 3 towers, the central of which is known as the Britannia Tower, built on a rock in the middle of the strait. Stephenson had the tubes floated out on pontoons and told his young engineers, "You must only raise the tube inch by inch, and you must build up under it as you go. Every inch must be made good. Nothing must be left to chance or good luck." Mr. Edwin Clark was the resident engineer. Joseph Locke and Isambard Kingdom Brunel visited the works. Captain Claxton directed the numerous corps of sailors. Robert Stephenson was the master spirit of the undertaking. On the 5th of March, 1850, he put the last rivet in the last tube and passed through the completed bridge, accompanied by about 1,000 persons drawn by 3 locomotives. Throughout the age of steam, the bridge carried the Royal Mail, passengers, freight, livestock, a staunch link in the chain of communication between Britain and Ireland. In the diesel age, stringent tests and measurements proved that the bridge was fit for service far into the future of freightliners and intercity expresses. But on the 23rd of May, 1970, a group of boys illicitly exploring had touched off tragedy. Many years ago, the tubes had been roofed with timber. Generations of engineers had coated the structure with protective tar, so it burned like a gigantic torch. As the tubes heated, expanded, softened, sagged and cooled, they split from top to bottom at the towers. After 120 years, the Britannia Bridge was no longer fit for traffic. The tubes were sagging and had surrendered all their strength. Army engineers rapidly assembled trestles made of Bailey Bridge units as a first aid measure, like splints. The first meeting to plan the reconstruction was held at Stephenson House in London. By now, British Rail's engineers and their consultants could assess the worst and the best of it. The wrought iron tubes were done for, but the masonry towers and abutments stood secure. Tall-masted sailing vessels no longer tack through the straits, so now there is no need for square openings 100 feet high under the bridge, as there was in Stephenson's day. Economic engineering came into play. Steel arches were conceived which would support the tubes and the permanent way for the time being. With the tubes removed, the arches would eventually carry a deck for the railway and a deck for a new road above the railway. But now the engineers had to face the fact that the tubes were so weakened by the fire that it was impossible to lower them out of the way. They must first be supported by the new arches. And meanwhile, the only link between the mainland and Anglesey was Telford's Great Suspension Bridge of 1826. The harbour at Holyhead lay stranded on the edge of the Irish Sea, quiet and still, its flow of traffic reduced to a trickle. Telford's bridge was never designed for the mass motor age, let alone for the freight that ought to be crossing the straits by the trainload. At the Britannia site, Stephenson's latter-day successors began the job from the bottom up. They built 8 concrete columns to support the new girder work for the approach spans. They constructed coffer dams at the Anglesey and Britannia towers. There, and at the base of the Carnarvon Tower, they laid the foundations for the 12 bearings which would take the thrust of the arches. The girders for the approach spans came straight from the maker to the job. The first new steelwork to be manhandled into place. Away from the site, the men of 4 factories in different parts of Britain were, by now, making the components for the arches. In the factory yards, they laid out the first arch units and bolted them together as a practical trial of their work so far. The steelwork travelled over the very railways that George Stephenson and his son Robert had built in the 19th century. About 2 miles down the strait from the bridge site was their destination, Port de Norwich Harbour. Here the arch units were put together and loaded onto pontoons for the voyage to the site. Pontoon movements were timed to coincide with slack water at the changes of tide. The straits had to be closed to shipping whilst the pontoons were underway or moored at the bridge site. The extraordinary feature of the job was that the new arches had to be built under an existing structure which was barely able to support its own weight, let alone be any use as a platform to build from. And the builders had to contend with the forces of nature. The tidal currents run strong in the Menai Straits. Winds can be strong too. Rain, mist and sleet are frequent. When the steel is wet, it may be too slippery for men to work safely. So bridge building is slow, laborious, sometimes frustrating work.
On the bunker winch.
But day after day, the general foreman conducts his human and mechanical orchestra. Day after day, the arch structures grow out and up, section upon section from the tower foundations. Each section of the evolving arches is tied back to the shores and balanced on the central Britannia Tower. In 1851, Robert Stevenson said that the true and accurate calculation of all the conditions and elements essential to the safety of the bridge had been a source not only of mental, but of bodily toil, including, as it did, a combination of abstract thought and well-considered experiment, adequate to the magnitude of the project. In 1971, the general foreman on the Britannia site said that this was the bridge that sorted out the men from the boys. "18 months after the fire. To the discerning eye, the new shape of the bridge was becoming clear. There were 2 arch units still to fit, the keystone units of the Anglesey and Carnarvon arches. On paper, they're not difficult bits of the jigsaw. Out in the cold, wet, windy, tide-ripped straits, it may well seem more complex, more arduous, the outcome more uncertain. But if it can't be finished today, the men will start again early tomorrow. And, if need be, earlier still the day after. So, 20 months after the fire, the old tubes were completely supported, and the first train could move cautiously across the strait. For now, the approach spans and the arches were complete. The 8 concrete columns were taking the load of the approach spans. The 12 tower bearings had accepted the thrust of the Carnarvon and Anglesey arches. Robert Stevenson, engineer, was duly remembered. The straits were open to shipping. Trains were working regularly in both directions through the upside tube. Now the men who died on Stevenson's contract could relax in their graves. By the summer of 1972, it was all rather like the end of a battle. Our side had won, but there was a lot of clearing up to be done. Masonry to be faced up. Tests and checks to be carried out. Undercoat to be applied. Now the gradual work of removing the ruined tubes could begin. For now the major part of the task had been accomplished. Trains were running again all the way between Holyhead and London Euston. Robert Stevenson once said that his main consideration was to secure the maximum of result with the minimum of means. Today's civil engineers would not dispute his sentiments.